All right, let's jump right in. We're going to pull back the curtain on two of the simplest but honestly most powerful tools in all of computer science, stacks and queues. You might not see them, but they are the secret architects running so much of your digital life.
I mean, really think about it for a second. How does your browser's back button know exactly which page to go to? It's always the last one you visited, right? Or what about a printer? You send a bunch of documents to print, and it always prints the first one you sent. Behind these everyday things are these two beautiful, super elegant concepts.
And it all boils down to two fundamental rules. First, you've got last in, first out, or LIFO. The best way to picture this is a stack of plates. You put a plate on top, and that's the first one you're going to grab. Last one on, first one off. Then you have first in, first out, or FIFO. That's just a regular line, like at a coffee shop. The first person who got in line is the first one to get their coffee. These two ideas, they're everything.
So let's get specific. A stack is that LIFO data structure we just talked about, and it really only does two main things. When you add a new item to the top, we call that a push. And when you take that top item off, the one you just added, we call that a pop. That's it. You push on, you pop off.
Now on the flip side, we've got the queue. This is our FIFO structure. When you add an item to the very end of the line, that's called an in queue. And when you remove the item from the very front, the one that's been waiting the longest, that's called a DQ. So you add to the back and you remove from the front.
Okay, so let's just put them right next to each other. As you can see here, the stack is LIFO. Think plates. And you push and pop from the same end. The queue is FIFO. Think of a ticket line. And you NQ at one end and DQ from the other. It seems like a small difference, right? But that one tiny change in rules leads to completely different superpowers.
All right, let's talk stacks. Their whole LIFO thing, last in, first out, makes them amazing for problems where you need to reverse things or backtrack. I like to think of a stack as the secret brain inside a calculator.
And this leads us to something called reverse Polish notation, or RPN. Now, it sounds kind of weird, I know, but it's just a way of writing math problems without parentheses. So instead of writing 2 plus 3, you'd write 2, 3 plus. It looks a little backwards to us, but for a computer using a stack, it's a ridiculously efficient way to get the answer.
And the algorithm is just beautiful. You scan the expression from left to right. Anytime you see a number, you just push it onto the stack. Simple. The moment you see an operator, like a plus or a minus sign, you pop the last two numbers off the stack, do the math, and then push the single result right back on top. Let's walk through it.
So here's our expression. 2, 3, 1 times plus 9 minus. We start at the left. We see a 2, we push it. We see a 3, push it. We see a 1, push it. Right now our stack has 3 numbers, with 1 sitting on top.
Okay, next up is the multiplication symbol. So, what do? We pop the last two numbers off the stack, which are 1 and 3. We multiply them. 1 times 3 is 3, and we push that result, 3, back onto the stack. Now our stack just has a 2 and a 3.
We just keep going. Next is the plus sign. So we pop the 3, pop the 2, add them together to get 5, and push that 5 back onto the stack. See that? The stack now has only one number in it, 5.
What's next? The number 9. It's not an operator, so our rule is simple. Just push it onto the stack. Now our stack holds a 5 and a 9.
And finally, we hit the minus sign. We pop the 9, then we pop the 5. Now the order here is super important. It's the second number we popped minus the first one we popped. So it's 5 minus 9, which gives us -4. We push that result back on.
And that's it. We're at the end of the expression, and there's only one number left in the stack. That number, -4, is our final answer. It's such a perfect example of how the LIFO principle just elegantly keeps everything in the right order for the calculation.
Okay, so let's shift gears and talk about queues. If stacks are all about going deep and then backtracking, queues are about exploring wide, level by level. This makes them absolutely essential for things like mapping out a network or finding the shortest path in a maze.
And the classic algorithm here is called breadth first search, or BFS. The whole point of BFS is to start somewhere and then explore all of its immediate neighbors first before you move on to their neighbors. It's like exploring in rings, moving steadily outward.
So how does it work? It's all about the queue. You start by adding your starting point to the queue. Then you just loop. As long as the queue isn't empty, you dequeue a node, process it, and then add all of its neighbors that you haven't visited yet to the back of the queue. You just do this over and over until the queue is empty.
And the real magic here is that FIFO principle.
Because we're always processing nodes in the exact order they were discovered, we're guaranteed to explore an entire level of the graph before moving to the next. It's exactly like ripples spreading in a pond. The queue makes sure that wave expands evenly, never skipping ahead. Okay, you've got the fundamentals. Ready for a quick bonus round? Stacks and queues might seem simple, but they're the building blocks for some really clever and powerful techniques that pop up all the time in coding interviews.
One of these is called a monotonic stack. Don't worry about the fancy name. It just means you keep the items in the stack either always increasing or always decreasing. It's an amazing trick for solving problems like finding the next greater element for every number in a list. And there's a great little rule to remember. If you're looking for the next greater thing, you build a decreasing stack. If you're looking for the next smaller thing, you build an increasing one. Kind of counterintuitive, but it works.
Now for a classic brain teaser. Imagine you need the first in, first out behavior of a queue, but the only tool you have is a stack, which is last in, first out. How in the world could you build a queue using only stacks?
The answer is so clever. You use 2 stacks. The first stack is your inbox. You just push all the new items onto it. But when it's time to dequeue, you take everything from that first stack and pop it all onto the second stack. That one move completely reverses the order, putting the oldest element right on top, ready to be popped off. You literally turn LIFO into FIFO.
So if there's one thing to take away from all this, it's this. Stacks are LIFO. They are your best friend for anything that involves reversing, undoing, or diving deep into a problem. And queues are FIFO. They are the perfect tool for processing things in the order they showed up, being fair, and exploring level by level.
You know, once you get LIFO and FIFO, you start to see them absolutely everywhere. So next time you're clicking around an app or using some software, just take a second and ask yourself, wait, is this working like a stack of plates, or is it working like a line of people? You'd be amazed how many complicated systems are built on one of these 2 really simple, really beautiful ideas.